Hello guys, so we're starting our next chapter, which is polynomials. We're going to start off first by looking at these white notes, adding monomials with like terms, and then we will move on to the pink notes, our first pink notes titled polynomials. So first let's make sure we remember what a monomial is. It's an expression that contains one term. And it could be just a constant number like the number 5. It can be a variable, like the variable x, or it can be a product of those constants and variables, like our 8z negative 4y squared and 7a squared b to the third. Every single one of those would be considered a monomial because they are one term. Now when we have two or more terms that contain the same variable with corresponding variables having the same exponent, we consider them to be like terms. Let's look at the 4 examples of like terms. 6k and 3k are like. They both contain k. 5x squared and negative 7x squared are like because they contain both an x as well as the x being squared. So not only is the variable the same, the exponent with the variable is the same. We have 2 more like terms here and 2 more like terms here. All the same variables containing the same exponents. Now these 4 are examples of unlike terms, and we're going to examine why. 3x and 4y are unlike because they have different variables. The x and the y are not the same variable. In number 2, 5x squared and 5x to the third are not like. They do have the same variable x, but the exponents are different. These 2 terms, 9ab and 2a, are not like because the second term, 2a, is missing the b. So we could say 2a does not contain the variable b. And our last one, you have to take a close look at those. They both contain an x and a y, but look at what they did with the exponents. The exponents switched. This x is to the third power, this is to the second, where our first term has y to the second power and our second term has y to the third power. So their exponents are really different. When we go to add monomials, we kind of think of it as the distributive property. We have 9x plus 2x, which if we undid the distribution, we'd have 9 plus 2 times our x. Well, all we have to do is add these coefficients up front, the 9 and the 2 together, to get 11x. Here's another example where we're going to end up adding the 7 and the negative 3 together. Let's practice. 4c plus 6c. What we are adding is just the 4 and the 6 to get 10c. Negative 39 rs to the third plus a negative 22 rs to the third. Now let's make sure they are like. They have the same variables. Yes, they do. And do the variables have the same exponent? Yes, they do. So at this point, we simply have to add the coefficients up front, and we'll get our final answer. Negative 39 minus a 22, or you can add a negative 22. You'll get the same answer, and you get a negative 61 rs to the third. Notice when we're adding, we're not touching those exponents. Negative 19t plus 6t, just add our coefficients in front, and you should get negative 13t. Number 4, they are like, they both contain an f and a g. We are taking 14 plus a negative 1. I'd like everybody to throw in a 1 so that we know then to add 14 plus a negative 1 to get our 13, and we have our f and our g. We have like terms again here. They both contain an m. We are doing negative 1.5 and we are adding to it a 1.2, and we are getting negative 0.3 m. Just do that right in your calculator. Negative 4 xyz plus a 1 xyz plus a negative 7 xyz. So we're really taking a negative 4, adding a 1, and then adding a negative 7. Negative 4 plus 1 is negative 3, plus a negative 7 is negative 10. Bring over our x, y, z. Number 7, this first term is a negative 1. They are like terms, so we add a negative 1 plus a negative 3, and we get a negative 4, bringing over our like term, our like variables, x, y squared. Negative 16 x squared plus a negative 1 x squared plus 15 x squared. They are all like terms. They all contain x squared. Negative 16 plus a negative 1 is negative 17. Add 15, we're at negative 2x squared. So there we just did negative 16 plus a negative 1 plus 15. Here they're all again like terms. They all contain c squared d squared. So we're going to add a negative 6 plus a 9 plus a negative 3. Well, negative 6 plus 9 is 3. When we add a negative 3, we end up getting a 0. So our final answer there is 0. We don't want to add our c squared d squared to that because that would not be in simplest form. Number 10. They are all like terms because they all contain a to the third power. So we're going to add the 6 plus the negative 8 plus 13 plus a negative 4. You can do that right in your calculator. 6 plus negative 8 is negative 2, plus 13 is 11, plus a negative 4 is 7, a to the third. Let's double check that for 11 everything is like, and they are because they all contain a b squared. 5 plus a negative 3 is 2. Plus a negative 10 is negative 8, plus another negative 8 is negative 16 b squared. Number 12, we need to find the perimeter of this following figure. Well, to find perimeter, we add all sides together. So we're adding 9a plus 9a plus 12a. They are all like terms, so we add 9 plus 9 plus 12, and we get 30. Number 13 is asking the same thing, to find the perimeter. So again, we will add all sides. I'm going to double check that they're all like terms, and they are. They all contain an m. So I'm going to add 7 plus 5, we're up to 12, 13, 14, 15, 16, 17, plus 4 is 21, plus 9 is 30, 30m. So there we just did a nice review and sheet on adding when we have like terms. So now we're going to move on to the pink notes titled Polynomials. And we're going to talk about some vocab on this first page. The first vocab word is degree. The degree of the monomial is the exponent on the variable. So we first have to locate the variable, and then we have to say what its exponent is. Well, the degree of z squared, z is the variable, the exponent is a 2. So z squared has a degree 2. For y to the third, we have to find the exponent on the variable. So the exponent on the variable is 3. So 4y to the third is degree 3. The degree of x, well, we don't see the exponent on there, but we could put a 1 to help us out. So the degree is 1. Now, letter D is a little bit harder. We have to make sure we understand the definition. The definition is the exponent on the variable. Well, there is no variable in just the number 5. We could technically say 5 is the same thing as 5x 0 power. So the degree of 5 is 0. When we look at different types of polynomials, which are the sum of monomials, we have 3 different types that we might have. We did already on our white paper discuss a monomial that has one term, such as 6x squared. A binomial has 2 unlike terms. We can't combine them, like 10a plus 2b. They're unlike because a and b are different. And there are 2 terms. And then a trinomial has 3 terms, and they're all unlike. These 3 are all unlike because this x has a squared, this x only has a 1, has its exponent, and then the 2 at the end doesn't have an x at all. So there are 3 separate terms put together called a trinomial. 1, 2, and 3. We need to know what simplest form means. Simplest form is when your polynomial contains no like terms. Everything that can be combined and added or subtracted together are already done. If we look at this one, there's 4 terms. 1, 2, 3, 4. These 2 terms here are like terms because they both have an exponent of 3. So those 2 terms can be combined. 5x to the third plus 2x to the third is our 7x to the third. Now we have a polynomial in simplest form because all 3 terms that are left are unlike and cannot be combined any further. The degree of a polynomial is going to be the highest of the degrees after it is simplified. So here's just like the one above. We simplified by combining our 5x to the third and our 2x to the third. So now we have a simplified polynomial, but now we want to find the degree of that polynomial, and it's the highest degree. And we learned in our beginning of this pink paper that the degree is the exponent on the variable. So the highest one would be 3. Sometimes you are asked to write a polynomial in descending order and sometimes in ascending order. Descending order starts with DE, so that might help you remember. We have to decrease our exponents going left to right. Ascending is when we're increasing going from left to right. This here is very important. The state likes to ask you a lot to put the polynomial in standard form. So when they ask you that, remember that is descending order going from left to right, or decreasing the exponents going from left to right, starting with the exponent of 3, going to the exponent of 2, going to the exponent with 1, and technically going to the exponent with 0. And there's the ascending order, increasing exponents as we go from left to right. All right, we're going to state the degree of these 3 questions. Remember, the degree is the highest exponent on the variable. Here, the highest exponent is 3, right there. Between these 2 terms, the highest exponent is 4. And here's that trick question again. It's the exponent on the variable. I don't see a variable there, so the degree is 0. We need to state whether 4, 5, and 6 is a monomial, 1 term, binomial, 2 terms, trinomial, 3 terms, or none of those. 7y, that is 1 term, so we call that a monomial. here, let's see how many terms we have. We can't combine anything. Everything is unlike, so it's as simplified as it can be. So I have 1, 2, 3, 4 terms. We don't have a special name for a 4-termed polynomial, so we're going to say none of these. And our last one here, we have 2 terms. The 14a squared is one term, and the negative 2b squared is another term. 2 terms is called a binomial. For 7 and 8, we need to do 3 separate directions. We have to arrange them in ascending order. So that's where our variables are increasing as we go left to right. Then we're going to put our polynomial in descending order, where our exponents are decreasing. And then our last one for number C, we're going to state the degree, which is the highest exponent. A, increasing. 9, remember, would have a 0 on the y, so that would be our first term. Our next term would be the next exponent going higher, so 3. Y to the third would be next. Notice I put a plus in front of that. The sign has to come with it. We have to know whether that y to the third is positive or negative. And our last guy is y to the fourth. Is y to the fourth positive or negative? We need to look up front. Well, there's no sign, so we know that that means it is positive. Now we want to go in descending order. It's just the exact opposite, starting with the highest and working our way down. And again, each term we have to say whether it's positive or negative. Now what's the degree of this polynomial? It is the highest exponent, which is 4. Number 8, we're going to start by putting it in ascending order or increasing order. I'm going to put a 1 on here to help us. So I see an exponent of 2, 1, and 4. The smallest is the 1. Now make sure you grab this sign with it. It is a negative 3a. The next going in order would be the squared, and it's a positive 2. And our last one is our a to the fourth, which also happens to be positive. Now we're going to go in the exact opposite order because we're going to put it now in decreasing order. So a to the fourth would be the highest, and we're working our way backwards. 2a squared is positive, but our 3a is negative, so we need to write a minus 3a. And the highest exponent happens to be a 4 again. Now we're going to move on to adding polynomials together, or sometimes a monomial with a polynomial. And in order to do that, we just have to remember to combine our like terms. Like terms have the same variable as well as the exponent on that variable. So if we look at this monomial plus this binomial, we have to just find the like terms. 7b and 4b are our like terms. 7 plus 4 is 11. And then there's nothing like our negative 6, nothing to combine with him, so we just bring minus 6 over. Number 2, looking at our monomial plus our binomial, we're going to key in on our like terms, and it's the 2 terms with the r. This is 1r. 1r plus 2r is 3r. There's no term like that s, so I'm just going to bring over the s. Here we have a binomial plus a binomial. Let's find some like terms. I first see our like terms of c. 8 plus a negative 3 is 5. Bring over our c. I also have some other like terms that I'm going to add together. 7 plus a negative 9. They're like as well. And that happens to be a negative 2. So we'd write minus 2. Question 4. I see 2 terms with b to the third. Those can be combined. 7 plus 2 is 9. B to the third. And here's some more like terms. Negative 5 plus 4 is negative 1 minus 1. Here we have a trinomial plus a binomial. Same thing though, just key in on the like terms. This y to the third, I don't see any like term to add to that, so I'm just going to bring him over. I see two terms with y squared. Put a 1 in front of that guy. 3y squared plus 1y squared is a positive 4y squared. And then we have two more terms here to combine that are like. Negative 1 plus a negative 5 is a negative 6. Here we have a trinomial plus another trinomial. Find those like terms. I like to start with the highest exponent. You do not have to if they do not specify that you need to, but it's just something I like to do. So I'm going to start with my exponent of 3. There's nothing like this term. There's no other a to the third, so I'm just going to bring over my negative 2a to the third. Then I have some a squareds I can combine. 4a squared plus a negative 2a squared is 2a squared. Just use your calculator if you're not sure about adding the numbers. Our terms with a are like as well. Negative 6 plus 7 is a positive 1a, and there's nothing like our 3. So there's nothing to combine with him, so we simply bring over our plus 3. Here we're just adding 4 monomials together, but we have to make sure they're like to be able to do so. Well, I see some y's and adding them together. 9y plus 1y is 10y. And then we have our w's that we can add together. 6w plus 3w is 9w. Question 2, I'm going to add my a's together. Negative 4 plus 3 is negative 1a. Then I want to add my b's together. 6 and a negative 1. 6 plus a negative 1 or 6 minus 1. Either way, you will get a 5b. Number 3, I'm going to add my m's together. I see a couple like terms with an m. Negative 5 plus 3 is negative 2m. I see some n's. Oh, look what happens here. 6 plus negative 6 or 6 minus 6 is 0. So actually, those end up canceling each other out. And we have nothing like that 8p to combine with it, so I'm just going to bring over my 8p. Number 4. Now I know they all have x's, but in order to combine, they have to have the same exponent as well. So my x squareds can get combined. 4 plus a negative 1 or 4 minus 1. And then my x's. 2 plus a negative 8. And then we have our whole numbers here that we can combine. Negative 7 plus 7. Oh, that's 0. So those end up canceling each other out. Now we need to find the sum of the following polynomials. Where again, sum means to add. We're going to add a little bit more. Binomial plus a binomial. Find our like terms. 5x plus 6x is 11x. 3y plus 9y is a positive 12y. Find our like terms. AB can be combined to another AB. So negative 9 plus 3 is negative 6. And then 8 plus a negative 8, because they're like with CD, CD. Those cancel out. 8 plus a negative 8 is 0. Let's add this trinomial plus this trinomial. 15 plus 3. We can add those terms together. They both have an x. That is 18x. Then we can combine our y's. negative 26 plus a negative 14 is negative 40. And lastly, 8z and negative 3z, we can combine their like, and they combine to a positive 5z. We have a trinomial plus a trinomial again. We can add our x squareds together. 1x squared plus a negative 4x squared is negative 3x squared. Then we have our terms with an x in it. Negative 33 plus 18 is a negative 15x. And then lastly, we can combine a 15 plus a negative 36. 15 plus a negative 36 is negative 21. Last one. Here's like terms. They both have a squared. Negative 5 plus 7 is 2a squared. Negative 6ab can be added to a 6ab. They're like, oh, they end up canceling because negative 6 plus 6 is 0. And then negative 4b squared plus a negative 3b squared is negative 7b squared. And that is it. So thank you guys very much for watching this video. You guys have a great day, and let us know if you need help with anything. Bye-bye.